Do we know what we see, or do we see what we know? Realism or Reductionism by Perry Smith. Today, there are two very common views about the ontology of the world. One of the most common is called reductionism. It is an idea that all things are reduced to small particles or energy. Another is hylomorphism. Hylomorphism claims that all material things consist of matter and form. Hylomorphism is true for two reasons. One, because it gives us the best explanation to understand our findings in modern science. The second is because it is extremely useful because of the knowledge obtained through it. And only through this knowledge can we easily live our daily lives. A person who only has knowledge of essence and quality, and not quantity, has a great knowledge of things of the external world. But a person who has knowledge of quantity, without any knowledge of essence, ends up knowing nothing. The most common adhered to school of thought is called reductionism. We implicitly learn this philosophy in school growing up. As a youth, we are shown the periodic table, and we learn about the atom and subatomic particles within it. However, we learn nothing about the Aristotelian idea of form. Instead, we are taught that things such as color are nothing more than different light waves, and sound is nothing more than a vibration. One of the key people who are associated with the origins of reductionism is Isaac Newton. Through Isaac Newton's new outlook at ontology and his emphasis on quantity, he was able to make very accurate predictions in the motion of objects. This led to many people adhering to his ontological beliefs. Through his research in physics, which allows him to know many different things, which surely contains much truth and knowledge, it does not guarantee the validity of his beliefs regarding ontology. From his foundation, we see much of modern physics. It has led to the ability to predict projectiles with extreme precision almost perfectly. It is also through his research that we are able to send people to the moon and move a single atom in an accelerator. From Isaac Newton came the view that all things are reducible to the physical reaction of particles. This, in turn, generated the modern understanding of the atom. In modern science, we learn that the only difference between elements or molecules from each other is not from the quality, but by quantifying the matter or the atomic number. Even the variations among different states of water, such as liquid or gas, has to do with quantitative changes, such as the distances of the electrons and neutrons from each other. However, in reductionism, there is no immaterial thing that determines a thing's type of being. This means that the concept and idea we have of water, gold, or oxygen is not a real thing, but something simply formed in the mind. This new philosophy has drastic changes on how we interact with the external world. We no longer see the green grass. Instead, we see the grass and project greenness upon it. For greenness is not in the grass itself. Greenness itself does not exist, but rather it is the light that hits the grass and comes back at a specific wavelength. This wavelength is then interpreted as green in our mind. Reductionists also claim we do not hear sound, for sound is something that exists in the object. Rather, sound is simply a vibration. Different vibrations are then turned into different pitches by our mind. Things that were once understood as gold or water are not really differentiated by their essence and qualities. Rather, the only thing that separates gold from water is a number of particles within them. Scientists say that it is merely the number of protons that separate gold from silver, and nothing more. There is no form or qualitative difference. In this new system, the external world doesn't really exist. It's simply a projection made up in the mind. Man's view of reality is ultimately a lie. The reductionist claims that what one sees is not really the external world, but a projection. For reductionism claims the real world is nothing more than the quantitative location of particles. Not only is reductionism problematic insofar as it means we are ultimately living a lie and not seeing what is really there, but there is a problem in terms of concept versus quantity and what comes prior. For it is an equivalent of the chicken versus egg scenario. In this classic question of which comes first, the chicken or the egg, the answer is ultimately the chicken. For even if the first actual egg existed before the first actual chicken, it is a chicken that must pre-exist because the egg only exists for the sake of one day becoming a chicken. Thus, the concept of chicken must exist before one can create an egg actually or conceptually. However, the reductionist claims the egg is more important than the chicken. In the reductionist view, quantity is considered most important and reveals a true understanding of the external world, whereas quality is secondary and a figment of our imagination. However, there is a problem. We know quality before we know essence, and essence before we know quantity. Or we could say it in terms of knowledge. Essence and quality is prior to quantity. We must have a knowledge of a thing in order to quantify it. To put this in Aristotelian terms, we can say that quantity is an accident that only exists in a subject. As I have stated, modern physics is attributed to the discoveries of Isaac Newton, and it is the grounds by which many people hold to the reductionist view. The many achievements that have been attained through modern physics is a sign of progress that man has been able to accomplish with his quantitative knowledge. It has made the unimaginable possible, such as landing on the moon and returning, and the ability to control a single atom in a super accelerator. To understand the defects of a purely quantitative system, we must first start with something that can be fully explained quantitatively. Even if we start with the smallest particle, we have not attained a standard. We tend to think of electrons, protons, and neutrons as little balls orbiting a nucleus. However, this is not agreed by modern science, for these balls are actually made up of smaller things, which are themselves made up of even smaller things. Assuming there is a smallest particle, we are still not left with pure quantity, for we still have a concept or an idea. When we imagine this small particle in our head, we impose quality on it. Once we attribute extension and existence, it will naturally have accidental qualities, at least in our understanding. As we continue in our knowledge or understanding of the small particle, we will claim it has certain accidental qualities and behaves in a certain way with other particles. To make these claims is to attribute a form or concept of this thing. Thus, the world cannot be comprehended with pure quantity, for eventually, man must refer back to some sort of form or concept. Thus, one could not comprehend the world or the quantitative without referring to some sort of essence. Modern technology has allowed us to observe the atom as a microscopic level that was never before possible. At this extremely small level of examination, we did not find the perfect mechanistic world, and this puzzled scientists. Albert Einstein referred to this finding as spooky. The traditional mechanistic paradigm was overturned, and new theories would need to be devised. One of the bizarre findings upon examining subatomic particles was that though we were able to, with extreme accuracy, predict and calculate the probabilities for the projection of particles, they do not necessarily follow a perfect mechanized trajectory. This came to the creation of what has been called Bell's theorem. This theorem basically states that the motion of subatomic particles cannot be predicted through the laws of physics. Unlike a ball that I hold in my hand, if I throw it, by knowing the laws of physics, the properties of the material in the ball, and the wind speed, I can perfectly predict the trajectory of this object. However, with subatomic particles, this is not the case. Understanding the nature of the electron, or its electronness, is not sufficient for determining how the electron will act and respond. This means that a mechanistic view of quantity does not provide all the answers for explaining the external world. Although on a macro level, the mechanistic view of Isaac Newton was very successful, on a micro level, it has failed to predict the motion of subatomic particles. The perceived world or everyday life is a place where we can experience and encounter things, and is also referred to as the macro world. Here, things can be produced according to the physical mechanistic explanation of Isaac Newton. However, on the micro or subatomic level, things are very different. This new understanding of the micro level has caused scientists to come up with new explanations of the atom. All the systems have to cope with the fact that what is perceived and known by the essences, or on the macro level, behaves mechanistically. Yet that which is only known through instruments that are smaller than what can be sensed has a different rule for its motion and action. The Aristotelian would say, we know sense objects because we know their natures, and it is from a knowledge of this nature that we understand how they work and function. Though we can grasp the nature of things on a macro level and predict their motion with great certainty, we cannot appear to grasp the nature of things on the subatomic level. These particles do not always behave in accord with the way we understand their nature. The downfall of the traditional mechanistic view has led to man embracing all sorts of new theories. Though there is much attempt to restore the age-old theory of reductionism, new theories try to understand the motion of these particles through looking at the atom as a whole, instead of just looking at the individual subatomic particles. This is because, to predict the motion with great probability, one must have a knowledge of the entire atom, and not just a particular subatomic particle. For it would appear that motion is determined not by something intrinsic to the property of the subatomic particle, but rather by studying the entire atom, which the particle is intimately connected to. These new views explaining the trajectory of the subatomic particle rely on a holistic understanding of the atom. This is the beginning of acknowledging the existence of the Aristotelian concept of a substantial form. When scientists first tried to make sense of the subatomic particles, it was because the motion of these particles did not coincide with the scientists' concept of these particles, causing them to conclude that there was a problem. We could say that through this process, scientists were imposing a form or nature on the subatomic particle. However, now scientists are attributing the nature or principle of motion not to something intrinsic to the subatomic particle, but to something intrinsic to the atom as a whole. This is the beginning of acknowledging the atom, not as a conglomerate of parts, but as having a unifying principle that makes the atom one single thing. This is what Thomists call a substantial form, or as was clearly stated in St. Thomas's commentary on Aristotle's physics, it is a substantial form of an object that determines its motion. Deep within the perennial philosophy lies an alternative to the mechanism we see in Newton. It is a Thomistic and Aristotelian ontology of HYLOMORPHISM. This system claims that all material things are a composite of matter and form, and it solves many of the problems of mechanism in light of modern science. The bizarre phenomenon we see of the subatomic particles in an atom can be explained analogously by the relation to virtual substances in a human. Just as man is one substance, and things such as calcium and other materials virtually exist in him, or in other words, things appear to exist, such as calcium, which does not actually exist as calcium, because it does not have a substantial form of calcium. A similar scenario can be in an atom. For when an atom seemingly has particles in it, such as electrons, protons, and neutrons, these things do not actually exist in their own right. Rather, they exist as a part of the entire atom. Thus, while these subatomic particles are part of an atom, they do not have their own essences and natures, but rather the matter is given its very being from the essence or substantial form of the atom itself. Thus, the atom is not a pile of subatomic particles. Rather, the atom is one thing with multiple parts. Since the subatomic particles do not have their own nature, but attain their nature or principle of motion from the substantial form of the atom, we now have an explanation for why the motion of the atom can only be understood from a comprehension of the entire atom, and not just a comprehension of the individual subatomic particles. We have now seen that an Aristotelian Thomistic ontology is able to solve for some of the problems that mechanism is incapable of dealing with. Now, some people object and claim that we cannot go back to Thomism because it is incapable of accounting for the many significant findings of Isaac Newton and his great advancements in the quantitative sciences. However, there is no reason there needs to be a disunity between the quantitative sciences and Thomistic philosophy. There is a movement called Riverforest-Thomism, which has combined the quantitative knowledge of Newton with the qualitative and essential knowledge of Thomism. One of the leading figures in this group was Father William Wallace. Through his book, The Modeling of Nature, he did an excellent job of explaining the atom through both the quantitative aspects as well as a philosophy of Aristotle and St. Thomas Aquinas. In his book, he made similar comments about subatomic particles and asked the question of whether a subatomic particle even has an essence. Just as calcium is not actually calcium when it is part of the body, so also subatomic particles, such as electrons, do not exist as actual electrons when they are part of an atom. But a deeper question is, do electrons even exist apart from a substance? Do they ever have their own essence? Unlike the virtual substances in a man, we do not observe subatomic particles. We do not encounter them with our senses. We run tests with very accurate quantitative tools, and they give us back math. We then combine this math with a model or idea, and we are able to predict how these subatomic particles act and function. Actually, when we think of subjects, we always apply accidents to them. When we think about subatomic particles, we tend to think of little balls. However, the consensus is that electrons really aren't electrons, but electrons are reduced to quarks, and quarks are reduced to something even smaller. There are even some branches of science that say subatomic particles are simply charges, and all matter and substance is ultimately just energy. Since the subatomic particles are not truly observable, we cannot sense them. We are not able to accurately grasp them and come to a knowledge of their essence, or even know if they are actually a thing. This is also agreed by the reductionist, which has ultimately failed to grasp the building blocks that are really the only real thing in this universe. In this image above is a diagram of a powers model of an inorganic nature. This model seeks to explain the four forces of physics with a hylomorphic understanding of an atom. Beginning in the middle is PM. This represents prime matter. On the outside, it says NF. This is natural form, for the PM and NF are together, and they permeate the entire thing and form one substance. This accounts for the traditional hylomorphic account of the atom. In addition, we have four forces: the weak force, the strong force, the gravitational force, and the electromagnetic force. This is one example of how the river forest movement was able to combine the quantitative knowledge of modern physics with the qualitative and essential elements of traditional Thomism. This view is one that is holistic, containing a substance with essence, quality, and quantity. Whether you are a reductionist or a Thomist, the knowledge through which we first attempt to come into contact with the external world is through the senses. Once we grasp things through the senses, we then form concepts in our mind. These concepts are things such as gold, iron, or oxygen. For thousands of years, man could differentiate gold from iron, not by using an atomic number or periodic table, but rather simply through observation. Through knowledge of the essence, man knew things were essentially different. This knowledge did not come through a mere knowledge of quantity, but through a comprehension of the essence of the thing. It is only in recent times that we have learned about the atomic number of elements. Before this, man was completely capable of distinguishing the different types of things by his knowledge of their essence. For if in the beginning man was only given an atomic number, it would mean nothing. This number means nothing without a concept and idea for it to be applied to. For quantity means nothing when it does not apply to a concept. However, it was through experience that man first realized there were different types of things outside of himself. And only after first having an experience and knowledge of the essence was he able to begin to look and probe into what differentiates these things, that he realized the difference in quantity and internal structure. For if man only had knowledge of the atomic number and the atomic structure, he would not be able to live his life or be able to go about daily simple tasks. However, a knowledge of the essence of a thing that contains both quantitative and qualitative attributes allows man to live his life in the real physical world. The fact that man can only come to the knowledge of the different atomic numbers or quantitative structure of elements after he has first comprehended their essences through qualities is evidence that, at least in the order of knowing, essence is prior to quantitative knowledge. It is actually this quantitative knowledge we typically refer to when we speak about gold or silver. Thus, the essence is prior to the quantitative. For when man first seeks to know, he starts as a blank slate and comes to know qualities through his senses. By knowing qualities, he comes to observe things and knows the essence of things. Once he knows of the subjects around him, he is then able to know of quantity. Thus, in the order of knowing, quantity is the last to be known. It is only after one first knows the essence and the quality. If quality and essence do not exist, then that which quantity is predicated of is a lie. Thus, if that which we have quantitative knowledge about does not actually exist, then quantitative knowledge ends up giving us knowledge about nothing. There are additional objections to the tendency to reduce quality to structure. The reductionist reduces the quality of color to a quantitative wavelength and the quality of sound to vibration. This is because the quality of sound or vibration is always found together, just like essence and atomic number. However, correlation does not prove causation. Though the reductionist assumes qualities do not exist, he does not prove this principle through necessity. It is merely an assumption. Arthur Eddington was a philosopher who compared aspects of modern science to a fisherman with a net. Just as a fisherman will not catch fish smaller than the holes in his net, a scientist will not make certain observations if his principles assume they do not exist. Thus, the world of essence and quality are ignored by modern science, not because of empirical verification, but because of assumptions that claim a correlation demands a causation. We see that without essence, quality has no meaning or significance. For the sake of accomplishing basic everyday tasks, qualitative knowledge is only helpful when it is combined with essence. The average person does not need to know the quantitative aspects of knowledge of substances but they do need an understanding of substances on the sensible level. This is a knowledge of essence and quality. To perform simple tasks, such as to read, to walk, and to drive, rely on us knowing the essences of things around us, and knowing both the quantitative and qualitative attributes, not just quantity. Thus, it is a knowledge of qualities and the essences of things that will allow us to perform practical tasks in daily life. Therefore, the pragmatist will prefer to adhere to the realist position. This very system provides the knowledge he needs to understand the external world and live his daily life. If he does not acknowledge quality and essence, he will not be able to make it through his daily chores. Also, the scientist needs realism to read the instruments by which he attains his quantitative information. Also, theories of realism, such as HYLOMORPHISM, can explain certain problems in modern physics, such as the non-locality of subatomic particles, where reductionism has failed. Ultimately, since a philosophy which only is concerned with quantity and rejects the existence of essence and quality cannot provide true knowledge, because quantitative knowledge is always knowledge of something, and if essences turn out to be nothing, then quantitative knowledge turns out to be knowledge of nothing.